On our third day of working in section 5.9 with ax squared plus bx plus c, we're going to do page 222. The assignment is 37 to 44. We're going to do problems 37 and 43 together. I'm going to show you just a couple of tricks. On number 37, we'll use some substitution to try to make this look a little easier. It's not the only way to do it, but it may end up working pretty well for you. Once you get past the need to use a technique like this, you know you're in pretty good shape. What I'm going to do here, just like we did on some of the problems in the past, we're going to substitute in a variable for your binomial a plus 2 and rewrite the problem. So when that gets rewritten, we're going to make that 2x squared plus 5x minus 3. And we're going to factor that just like the binomials aren't in there. Once we're done, we'll feed that back in for x, the a plus 2. So let's factor this out. We got 2, we got 3, and we're trying to get to 5. And the way that happens is either 6 minus 1, or, let me rewrite this. And one of the main questions I get is, how do you know the difference? So we'll cover that. So you can do 6 minus 1, or you can do 2 plus 3 to get to 5. So right here, what I want you to think about when you're trying to figure out which of these does it need to be is 2 times 3 is going to give you 6. 1 times 1 gives you 1. And you're trying to get to a positive 5 in the middle, meaning the 6 must be positive, the 1 must be negative. When that gets factored, you're going to have x and 2x, in whichever order you choose. The 2 will pair with 3, and the 1 will pair with a 1. Now for that 6x right here, to be positive, that's your plus, and the other one is your minus. If you do it the other way here, the second one down, what you're going to have is x and 2x. And the 2 and the 3 both pair with a 1. Now 3 times 1 is 3, 2 times 1 is 2, and the only way to get to 5 is if you add everything up, so it has to be pluses. And look at your, now I have done something wrong here. That should have been a 3, excuse me. Look at your sign. Look at this minus 3. This is what tells you which way is correct. Here you were using a difference method, giving you a minus last term, a negative last term. Here you're using a sum method, which gives you a positive term. Right? So don't use the sum method, use the difference method when you see a negative number there. You can't use the same signs in both terms to get a negative end. Now you've got x plus 3, 2x minus 1 is what you factored this condensed version down to. Remember that what we did up here was we substituted x for a plus 2. So now we need to undo that substitution. So in your next step, everywhere you see an x, you need to put an a plus 2. Now you notice here you've got 2 times x. So that's going to be, I'm going to nest parentheses here, 2 times a plus 2 minus 1. Now you can simplify within these parentheses. That's going to be a plus 5. And your second set, this is 2a plus 4 minus 1. So you have 2a plus 3 to arrive at your answer. Now, as you get more accustomed to these, more other things will come out. But until you reach that point where you've done enough of these that you find other methods on your own, I'm going to just insist that you use this method to keep things easy. Let's look at the second problem, number 43. And note right here, you've got y squared plus 3y minus 1 to the second power, minus 9. And you need to do a factoring pattern on this. Now, you might start out on a couple of different paths with this. Some of you might try to actually multiply all this out, which is fine. I mean, that is a technique that you could use here. Let's play with that and just see what comes of it when we do that. If it's y squared plus 3y minus 1 to the second power, what that means you're going to have to multiply two of these together and combine your like terms. So you're going to start with y squared and you're going to distribute that to all three terms. Then you'll go back and do the same thing with 3y, and then you'll repeat the process with negative 1. So what you'll have is y to the fourth plus 3y to the third minus y squared. Now we're going to go back to the 3y and do it again, plus 3y cubed plus 9y squared minus 3y, and now we're at the negative 1 on the first trinomial, minus y squared minus 3y plus 1, and then we're to the minus 9 portion. Now combine like terms. On here we've got a y third, a y to the third, that's it. Let's look at y to the seconds. There's a y to the second. There's another one. And then just y's. And then let's combine our constants down here. Now the y to the fourth is my leadoff term. If you combine your yellow highlighted terms, you have a positive 6y cubed. Let's look at green highlight next. If you do a negative y squared plus 9 minus 1, then you've got a positive 7y squared. Minus 3y minus 3 more y is minus 6y. And finally, you've got 1 minus 9, which is negative 8. All right, now if you went that route, you have to try to figure out what are you going to do next. And at that point, you might realize that you're getting yourself stuck. You can do common factors of specific terms, but you haven't done factor by grouping yet, which is from section 510. And you're going to end up creating a big mess. So let me show you way two. I'm going to erase that. So that didn't work. Let's try something else. What I do notice is that this is a squared, and this is a minus, and this is also a square. This is actually a difference of two square problems. And I'm going to try that substitution trick again, but this time I'm going to make x equal to y squared plus 3y minus 1. And I'm going to rewrite the problem, which would simply become x squared minus 9. Put that in parentheses. So x squared minus 9, if you're going to factor that, is a far simpler task. You get x plus 3, x minus 3. Now, just like we substituted on the last sample problem, what I want to do now is put y squared plus 3y minus 1 in for each x. So your first term, your plus 3 term, put your y squared plus 3y minus 1 in there. And then on your second term, do the same thing. It's just going to end in minus 3 instead. So y squared plus 3y minus 1 minus 3. And then simplify those. In your first set of parentheses, you're going to make that y squared 3y, that's a plus in there, plus 2. Let me widen this out just a little bit. And in your second set, that becomes y squared plus 3y minus 4. So what you got is two trinomials. Now where this originally was not factorable, if you had tried, you'd realize you can't do 1 times 1 to get to 3. You can do 2 times 1 to get to 3. And you can do 4 and 1 to get to 3. So both of these can be further factored into binomials. So your first one, let's look at this one is going to be here. Put the second set of parentheses in. And then this one I'm going to factor to here. So you got y and y, you got 2 and 1. And the only way to get to a positive 3y is if both of those are pluses. Now in my second set, I've got y and y. And the only way I can get from 4 to 3 is to do 4 and 1. Notice that's a difference problem since you have a negative right there. It's got to be a positive 4 and a negative 1. So your answer breaks down into 4 different binomials. If any of these were the same, you could use exponent notation. But since they're all different, you can just leave them in whichever order that you'd like. Alright, so your assignment is 37 to 44. Be careful of starting out on the wrong path like we did as an example for this one. You have to reset, try a different technique, and you might have to dip into the last couple of sections from 5.7 and 5.8 to figure out what your end result's going to be.